So, hello everyone. My name is Nathen Harvey. I lead up Dora at Google Cloud. As Otto said, you might know Dora for those four key measures. We'll talk a little bit about those, but if you take away nothing from this talk, let it be this one thing. Well, so hopefully not nothing, but at least one thing. And that is Dora is really a program that is meant to help teams get better at getting better. This is a journey of continuous improvement. I love John's call out for all of us to have intention behind what we're doing. So if you can have an intention to improve just a little bit today and a little bit more tomorrow, that sets you right on the journey to achieving whatever it is that you're setting out to. So Dora, just a little bit of history. Dora's been around for over a decade now. We've been publishing research, investigating what makes teams high performing and how do we even define high performing teams. This research program has looked at organizations of every shape and size from right around the entire world. We've learned so much. And for that, I want to say thank you, because it is through participation in the research program from teams and people like you that we're able to get these findings and publish them out, share them with the world. And publishing research is really, really important. And those of you that have read the research, we thank you for that. But the biggest, most important thing from my perspective is it's about the teams that take this research and contextualize it within their own environment. So we publish this research, and each year we publish a report. So maybe you've had a chance to read the 2024 report. That's the latest annual report. I have other words to say later towards the end. But if you haven't, you can go grab that report right now. You can scan that QR code or follow that link. So I highly encourage you to download and read the report. Now, I have to admit, the report is about 120 pages long. So if you haven't had a chance to read it, I recommend not trying to read it right now. But there's lots and lots of great insights there. But I want to give you some of the insights that we talked about. And as you might expect, 2024, we really look at this as Dora has entered the era of AI. Maybe just like most of you, AI has really taken over a lot of the conversation that we're having. How do we use AI within our organizations? What are the impacts of AI and so forth? Dora feels very fortunate because as an industry, as we start to take on this new capability and this new way of working, it's an exciting time for us as researchers because we expect to see the impacts of this over the coming years. And we really want to understand how do you get the most value out of that. So before we talk about AI, I want to talk about what I consider the center of gravity of Dora. Otto mentioned those four keys. Those four keys help us measure software delivery performance. And software delivery performance really is, as I said, the center of gravity of Dora's research program. So how do we measure software delivery performance? Well, the research is a living thing. It's always changing. And in fact, in our most recent study in 2024, we did kind of change some of the ways that we look at software delivery performance. So I just want to talk about those right now. So we have this concept, this idea of software delivery performance. And one of the great things that Dora has done over the years is give us ways to measure that through those four keys. But I'm going to introduce a fifth key here in just a moment. When we think about software delivery performance, we really think about it as kind of two different factors. First is software delivery throughput. So how much change can we get through the system from, say, the developer's workstation or from the idea all the way out to customers where the real value happens? And it doesn't matter if those are customers or internal or external customers, they're users of your system. But it's not just about throughput, not just about pushing more change through the system. We also have to think about stability. How do those changes land in the production environment? And we take these two factors and we break them down, as I said, into 5 different metrics. So I want to just remind you or introduce you to what those 5 metrics are. The change failure rate is the expletive rate. It's when you push a change to production and something bad happens and you or someone around you shouts out an expletive. Oh, expletive, we better roll back that change or push forward a hot fix. Or, oh, expletive, my microphone has stopped working. Now, we also want to understand how long does it take to recover from that failure? And that actually is a measure of software delivery throughput, you'll see. That's weird. That's maybe interesting. Failed deployment recovery time, how is that a measure of throughput, not stability? Well, When you think about it, when there is a failure, you probably have to ship more change. Like you have to change something about the system, introducing more change. You can almost look at the difference between change lead time and failed deployment recovery time as a regular change process. How long does it normally take? And an emergency change process. Oh, we have an emergency. We need to recover. How quickly can we get those changes through? Okay, sorry, that was a little tangent. The microphone has thrown me off here a bit, but right back on it. Let's talk about those stability metrics again. We have change failure rate, so the expletives we need to recover from, but then also a rework rate. And the rework rate is the new thing that we introduced in our 2024 study. What we found was that rework rate really is a good measure of that stability. And when you think of rework, the way that we posed this question was basically thinking about the deployments that you've done in the last time frame, let's say 6 months. How many of those deployments were not planned deployments, but rather were done to fix a problem or address maybe a security issue or something like this? We consider that rework. We want rework and your change failure rate to go down. We want your change lead time and deployment to also shrink. Your deployment frequency should go up, and your failed deployment recovery time should shrink as well. But overall, this is how we're now thinking about software delivery performance. Now, one of the things about these measures, the metrics on the right-hand side, we can use these to measure the performance, the software delivery performance of any type of application or service that you're working on. It could be a mobile application, it could be a mainframe application, it could be a little toy application that you're using just for fun, it could be the platform that you're delivering to other users. You can use these metrics to measure that software delivery performance. But there is a caution. You don't use these metrics to compare the software delivery performance of those disparate applications, because the context and the goals and the intention of each one of those applications is different. So you're not really comparing apples to apples. Okay, let's talk about another thing about these performance metrics. You know, when we, in our research, when we look across these performance metrics, we look at the best of the best performers when it comes to software delivery performance and the worst, the lowest performers, those performers with the most opportunity to improve. And we see very stark differences. Now, it should be noted here that we don't see stark differences between throughput and stability. What our research has shown us is that these tend to be correlated. They move together. In other words, there isn't a trade-off. You don't have to decide, should we be fast or should we be stable? The truth is that in order to be fast or in order to be stable, you have to be fast. These two move together. We see tremendous differences between, like I said, the elite performers and the low performers, but ignore those differences is my plea. So why did I put them in the slide? Well, because everyone always wants to know, how do we go against these benchmarks? But the thing is, the only performance comparison that really matters is a single team versus its past self and versus its future self. Again, we're on a journey to get better at getting better, to continuously improve. And those are the best comparisons. How are we doing over time? But I want to just bring it back to these software delivery performance metrics and why do they matter? We have shown through our research that these performance metrics, both software delivery performance and operational performance or reliability, are important. And we should understand how we're doing for the applications and services that we're working on. But why are they important? Well, first and foremost, these performance metrics are good predictors for outcomes that we care about. Outcomes like organizational performance and well-being for the people on the team. You know, you and I. Less burnout, that's what we want. Higher job satisfaction. These are all characteristics of good well-being. So in that sense, these delivery performance metrics are leading indicators for those outcomes. That's awesome. But how do you improve software delivery performance? Well, I'll tell you one way you don't improve software delivery performance is by thinking about deployment frequency really hard. If I just think about deployment frequency, or maybe if I just mash the deploy button over and over again, my software delivery performance is going to improve, right? Well, sure, maybe the numbers are going to improve, but are you actually improving anything? So as we seek to improve our software delivery performance, it's important that we think about the capabilities and conditions that are predictive of software delivery performance. So if those delivery performance metrics are leading indicators for the outcomes, they are trailing indicators for the capabilities and conditions that we have in our organizations. Things like a climate for learning, fast flow, and fast feedback. So with that context in mind, let's look at AI and understand how is AI impacting software delivery performance, organizational performance, and frankly, technology-driven teams and organizations. Well, we'll start with a bunch of graphs, and I'll walk you through all of the graphs and share some commentary here. This first graph really looks at how is prioritization of AI happening. And what you see here is that a large majority of organizations are reporting a slight, moderate, or even significant increase in AI prioritization. A small proportion of our survey respondents report no change, and a very small proportion report a decrease in AI prioritization. Now that's interesting. I think that this is important because this shows that organizationally, we are prioritizing bringing in this new capability right across all parts of our organization. But what's happening on the ground? What's happening with practitioners? Well, this chart breaks down how many participants in our survey are relying on AI for a series of different tasks. And although the type might be hard to read, I'll read you the ones that are right at the top there. We find that almost 75% of our survey respondents are using AI or relying on AI for writing code. Next up is summarizing information, code explanation, code optimization. Those are all the top ones. Oh, and documentation. That's also right there at the top. Now, this is fascinating. I think when you take these two slides, the previous slide and this slide together, what we're seeing is that from the top down, organizationally, we are prioritizing AI, more AI use cases across our organizations. But what this shows us is that also at the practitioner level or at the grounds up, the grassroots, we're starting to rely more and more on AI to accomplish the daily work that we're doing. This puts AI in a unique position where we have both that sort of ground up or grassroots movement adopting and the incentives and maybe the prioritization coming from the top down. That to me is really, really exciting. But what's the impact of all of this AI? And now this chart, I'm going to take just a moment to explain because it's a little bit different maybe than it's certainly more complex than the charts that we just looked at. Okay, so in this chart, we're going to look at the y-axis first, the vertical axis. We're looking at a number of different outcomes or maybe even conditions. Those on this chart are flow, job satisfaction, productivity, time doing toilsome work, burnout, and time doing valuable work. Going across the x-axis or across the bottom is a range of percentages. And what we're looking at here is, does that outcome, flow, for example, does it improve or decrease when we adopt more AI? And in this case, about 25% more. So that vertical dashed line is at 0. Things to the right go higher when you have more AI. Things to the left go lower when you have more AI. And so what we do is we look at all of our data and we basically have this model of all of these different conditions and capabilities and outcomes that people are caring about. And we say, well, what if let's run a simulation where we dial up the amount of AI adoption by about 25%. What would the expected outcome be when you do that? And what you can see here is that flow, job satisfaction, and productivity all increase. And between you and me, I think that's a good thing. We want, as a developer, I want to spend more time in flow. I want to improve my job satisfaction, my productivity, and so forth. On the other side, or the next one down, the fourth bullet there is time doing toilsome work. And that is at about 0.4% improvement. Or increase, I should say. So you're spending a little bit more time doing toilsome work. But let's just talk about those vertical bars coming out from the circle there. Remember I said we're running simulations on the model. So that vertical bar represents our level of uncertainty. You can see here that this vertical bar is pretty wide. So, you can probably say that your time doing toilsome work is essentially unchanged. The amount of burnout that you have goes down, and that's good. We want burnout to be reduced. And then there's this other one, time doing valuable work also decreases. Well, that's super interesting to us. Time doing valuable work goes down, but my job productivity and job satisfaction are improving. What's happening there? And time doing toilsome work stays the same. Well, we aren't really sure. The data can't tell us exactly what's happening, but we do have a few hypotheses, and I may get to them later, or I'll direct you to research that talks about some of those hypotheses. Let's look at, we looked at sort of here, we looked at sort of individual impacts. Let's expand the scope a little bit and look at some of the team and other processes that might happen. So you read this chart the same way. That vertical line is 0, to the right is higher, to the left is lower. So what do we see here? I'm going to read from the top. Documentation quality, we see a big improvement there. Code quality, code review speed, approval speed, all definitely improving. Cross-functional coordination across teams is basically right at 0. It's right on the line, and there's enough error there to say it's basically unchanged. And then the last two, technical debt and code complexity, are both on the left-hand side of that. Tech debt maybe crosses over to the positive side a little bit, but both tech debt and code complexity, we want those to go down. We want those to decrease, of course. Now, here's an interesting question for you, though, when you look at this. Let's take documentation quality as an example here for this little question that I have. So as you know, not every engineer loves writing documentation. In fact, we don't tend to prioritize it. And yet our research, and we've been looking into documentation quality for the last 4 years, our research into documentation quality shows the tremendous impact that improving your documentation quality, and specifically internal documentation. So this is not end user documentation. This is sort of documentation that's used on the team. It has a tremendous impact on your ability to deliver and operate software. It really improves all of the outcomes and the technical capabilities and conditions that you need in order to drive good performance. So we really want that to improve, and yet we have trouble prioritizing it. Well, here comes AI, and one of the things that AI is really good at is generating documents for us. Now, I should note that we aren't talking about documentation quantity, but rather documentation quality. Even so, we see a big improvement. But here's where it gets a little bit curious. Another thing that AI is really good at is consolidating and sort of summarizing documentation that exists today, or documents, or maybe it's research papers, whatever it is. AI is really good at that. And perhaps you've already used AI today to get a summary of something that was longer than you had time to read. So here's an interesting question. If more AI improves our documentation quality, does that mean AI is helping us generate more documentation? Or does it mean it's helping us get better utility, make better use of the existing documentation that we have? And I would propose to you that the answer is probably yes. It's probably doing a little bit of both of these things. And at the end of the day, the thing that really matters is that we're improving our documentation quality. So that's a really interesting story. And these two slides, I think, take it together. These two graphs paint sort of an optimistic picture of increasing AI adoption means we're going to lead to better outcomes. But unfortunately, that's not the whole story. For when we look further out, we sort of open up the aperture a little bit more. We started with sort of what are the individual impacts, some of the team and process impacts. Now let's look at a bigger part of the system, specifically software delivery performance. Going back to those metrics that I talked about for software delivery performance, you read this graph the same way, except one of the things that you'll notice is that both of the dots, both of our findings, are to the left of that vertical bar, which means that as you increase the amount of AI that you have in your system, your software delivery throughput is falling off. It's decreasing by about 1.5%. And delivery stability is dropping off even further by almost 7.5%. And there's certainly some error bars there, some uncertainty, but even the uncertainty on the throughput is all to the left-hand side. How can that be? Why is that? We saw that as we improve a bunch of things that typically lead to better software delivery performance is still going down. Why is that? Well, our data can't tell us, but we certainly have a number of hypotheses that help us understand this. And the first hypothesis that I would recommend that we think about is thinking back to the entire system and the idea or the theory of constraints. Do you know the theory of constraints? Essentially, what the theory of constraints says, if you look at a system where, things are moving through a system, somewhere in that system, there's a bottleneck. And any improvement that you make to that system that is not at the bottleneck, those improvements are basically an illusion. You're not going to improve the overall throughput or stability of that system unless you address the bottleneck. Which leads me to a question that I have for each of you. When you think about your own teams or organizations' software delivery process, the idea of writing code, testing it, getting it approved, getting it shipped out to customers, and so forth. Would you raise your hand if for any of you, the primary constraint, the thing that's holding you back, the bottleneck, is writing code? And I can't see you all, but I know that no one has raised their hand. The speed with which we write code is never or is rarely the bottleneck in our overall software delivery system or overall software delivery process. And yet, as an industry, I think we've been learning this new tool, these new capabilities with generative AI. And one of the things that generative AI is really good at is creating code for us. That's great. And we're all starting to learn how that works. But maybe we're doing that while sacrificing the overall system performance. In fact, that's what our data here would suggest. And when you think about it, we actually shouldn't be surprised by this. One of the things that we've found in our research is that one of the great ways to improve software delivery performance is to ship smaller changes and to reduce the amount of work that you have in process at any given time. Really get your teams to focus on flow through the system, not let's start more work. So if you think about how AI might be impacting those two ideas, well, in the time that it took me to create a small change yesterday, I now have AI that is very proficient with generating lots of code. I can now create a much larger change in the same amount of time. But a larger change takes more time to get through the system. It's harder to get fast feedback on a larger change. We may end up with more work in process. So to an extent, we shouldn't be surprised by these numbers. Of course, if we're focusing on something that is not the bottleneck, one that may have a net zero impact on overall system performance. But what we're seeing here is that sometimes focusing on something that isn't the bottleneck can actually make overall system performance worse. So that can be a real challenge for us. Now, another hypothesis, another thing to think about, like this isn't all doom and gloom. I think that Gen AI is here to stay, and we're seeing it, again, prioritized from the top, growing from the grassroots. Organizations want this in basically every job function right across the organization. I think another way to explain this is that we're seeing something that always happens with the adoption of new capabilities, new technologies, new processes. Immediate gains give way to a dip in performance. We sometimes call this the J curve, where you kind of eat the low-hanging fruit. We see some immediate gains, but then the performance is going to dip. And eventually, as we stay committed and continually learn and adjust how we're using this new capability, we come out the other side where performance really starts to take off. Now, I would argue that there are maybe a small number of organizations that have made it through that dip. And we want to go and learn from them so that those of us that are in the midst of the dip or at the very beginning of that dip, we can get more information about how to survive through this dip and really come out on the other side stronger than we are. And I also want to give you some tools that you can use. If you're on this adoption journey with AI, how do you ensure that this doesn't happen to you? Or maybe when it does, what steps can you take to move past this and get to a place where AI is really helping improve performance? And I think one of the biggest things to keep in mind is that you need good, strong feedback. Feedback loops are one of the most powerful things that we have organizationally and within our teams. Feedback tells us how we're doing. Are we progressing in the right direction? And if not, what should we do to counteract the bad direction that we're heading or to overcome some of the challenges that we have? And this is really the foundation of Dora. If I come back to this model, right, we want to improve software delivery performance. We don't improve it by focusing on software delivery performance. We improve it by focusing on and having conversations about and changing the capabilities and conditions that are on the left-hand side. Do we have a climate for learning? Well, what does that even look like? Dora's model expands even further, and this left-hand side, that capabilities column, is really where the research spends a majority of its time. We want to understand those capabilities and conditions that predict or that drive or lead to better software delivery performance. And we don't care just about technology or just about technologies. We care about tools, of course, and ways of working, but we also know that culture is the foundational part of all of this. Without the right culture, without a learning culture, without an idea that we can take risks and we can learn from failures and so forth, without that sort of culture, improvement becomes even more difficult. But it's not just technical choices like, are we using version control or not? Please tell me you're all using version control. But it's not just those technical choices, and it's not just culture and people, it's also process. What does your change approval process look like? One finding that we had in 2023, and we replicated again in 2024, is that teams with faster code review times tend to have about a 50% improvement on their software delivery performance. And again, it's not necessarily a surprise. The time it takes to do code reviews is oftentimes a bottleneck in your overall software delivery process. So if you had to pick one place, well, you should pick the bottleneck. But if you aren't sure where your bottleneck is, have conversations, figure it out. We have tools and capabilities like value stream mapping that can help us understand where our bottlenecks are. You can get those easily through conversations with your team. You might not be able to easily find them just looking at metrics, although you might, depending on the metrics that you have readily accessible to you. You don't necessarily need metrics. You need conversations, though. So if you improve your code review times, you can expect to see an improvement in your software delivery performance if code review times are a bottleneck. If they're not a bottleneck for you right now, there's something else. And so the idea here, the way that you can leverage Dora, is understand how you're doing today, set a baseline with those performance metrics, and then have conversations around which capabilities do we have strength in and which capabilities do we have opportunities to improve. And then that's where you make the investments. Invest on the capabilities that are holding you back and watch how change and improvement flows through the system. In fact, I'm kind of encouraging you to take on a hypothesis-driven development. Maybe on your team, you've identified that test automation is the thing that is lacking or that has the most opportunity to improve. Well, let's sit down and write a hypothesis. We believe that by improving our test automation capabilities on this team, we will see improvements in software delivery performance as measured by these 4 or 5 different metrics, and that those software delivery performance improvements are going to lead to higher productivity from our teams, less burnout, higher job satisfaction, and better commercial performance for our organization. So if we improve our test automation, can we improve the earnings per share next quarter by a penny? That maybe feels like a leap, but this is the process that you can get through to show, here's where I need to improve. Now the important work comes. Go do that work. Go make that improvement. Invest in that, change how you're working, and really understand how does that impact throughout the entire system. So maybe some concrete metrics that you can look at. And I don't want to spend a whole lot of time here because I really believe that the reason that we have metrics is to drive conversations. We have conversations so that we can drive improvement. So you start with some metrics, you have conversations, you come up with ideas, you go test those ideas, and you validate them by going back to the metrics. It's a nice virtuous circle. So how do you know if you're getting value out of code assistants? Boy, this is a big conversation that I'm in all the time. We have these new code assistants. What productivity are we getting out of them? Well, first and foremost, you won't know if they're being productive if they're not being used. So how many of the licenses have you allocated? How many daily active users do you have, and so forth? And remember, you can't solve a problem by simply buying a tool. You can't say, well, we bought a bunch of licenses and allocated them, so now everything's going to get better. We have to give people time and space to learn to use these new tools, to integrate them into their own workflows and so forth. So there's a few metrics that you can think about from code assistance, but move beyond those. We really need fast feedback on the changes. One of the things that we've found through our research is that about 40% of our survey respondents do not trust the code that's generated by AI. Well, how can we improve that trust? Well, one thing we can do is we can improve the output that's there, but maybe more importantly, we can improve the fidelity and the speed with which we get feedback. And feedback becomes one of the strongest enablers of driving real lasting change for your team. So what kind of feedback metrics do you have? Maybe there's metrics around your test automation. Maybe there's something around if a test passes, how confident are you that that change can go into production? It's an interesting question. Beyond feedback metrics, maybe you move up to team level metrics and you're looking at things like trust and productivity. You're looking at how much time are you spending doing valuable work and so forth. We also look at organizational metrics. We want to drive the use of a tool as far through the system as we can. The other thing that's really important about these varying levels of metrics is to remember who is the audience for these metrics. You know, I have to be honest, I don't think your CEO should care about how many deployments you did in the last quarter, but they absolutely care about what is the customer satisfaction that you have in the last quarter. So when we talk about these, we need to be able to tie the work that we're doing in engineering, how does that relate to the overall goals and mission of our organization? Tying those together is really, really important. And you need, with these metrics, you need to make sure that you're having those feedback loops in place. And I recommend getting those feedback loops in place through things like regular surveys, through retrospectives, through building communities of practice, and of course, through data analysis. You know, Dora collects most of its data through an annual survey. I encourage you, if you're not talking to your developers, not surveying developers on your team, I would suggest that you can't measure developer experience without talking to developers. Sometimes talking to developers in a scalable way means running surveys. It is really important that you use all of the tools that are available to you. All right, I know we're running very close on time. I have a couple of final thoughts that I want to leave you with. The first is a reminder of how Dora does its research. We go out and we ask as many organizations, as many people as we can around the world working in technology-driven fields and teams and organizations. We ask for input on how they're doing work today. But the truth is, you don't work at all of those organizations. You work for one organization, maybe two. You work on a team, maybe two. You care about a specific set of users and a bunch of things that they're trying to accomplish. So our findings are broad. I want you to use our research in your context. I say here, replicate our findings. And I don't mean replicate our findings by going and you yourself running a global survey and analyzing all of the data. I mean, replicate our findings by using our findings as the hypothesis for what you're going to do next. Use these findings as insights into how you and your team might improve. And then importantly, and I think this is a lesson that everyone that's here knows this lesson already, you cannot improve alone. It takes a community sharing and learning from one another. And that's exactly, thank you to Swarmia, that's exactly what we have here today. Through the Swarmia Circle, we've got hundreds of people that are learning and sharing information with each other right now. This is community at its finest. If the things that I've talked about with Dora and our research are of interest to you, I definitely encourage you to come over to the Dora community. At Dora.community, we get together regularly to share and learn with one another. Oh, and also I have one more bonus report for you. This report just came out last week. Dora released this impact of generative AI in software development. So I encourage you to read the 120-page report. That's the 2024 report, but I also recognize that you might not. So here's a 50-ish page report that is focused exclusively on this topic, generative AI in software development. So I definitely recommend that you go and grab that report from the QR code or the URL that's listed there. And with that, I'm done. And if we have time, I'm very, very happy to take some questions.
So first, Nathan, thank you so much. Really, obviously very top of mind topic, and lots of really great insight there. So thanks for that. A couple of questions that we got from the group. First, these numbers some of these numbers look small or trivial. Is it actually worth investing in AI tools for coding? This obviously that big documentation chunk is maybe worth it, but maybe not once you learn about the things on the left side of the zero. So.
Right.
Yeah, how do you what's your how do you think of how do you think businesses should think about the ROI of this?
Yeah, the ROI is a really important question. I think I'm going to lean back or reflect back on some of the things that John talked about. Like, what's the return that you're hoping to get on this? What are you intending to see? Because maybe it's not improving software delivery performance. Maybe it's improving job satisfaction for your development team. In which case, there's great evidence that you can just use Gen AI right now, and it will help with job satisfaction for the teams. Of course, I don't believe that Gen AI is the only thing that you can use, or that it in and of itself will improve job satisfaction. There's a lot more complexity to how satisfied am I with my job, but that might be one of the tools in your toolbox. So I think that's a piece of it. And then the other thing, I think, so being very clear about what is the return that we're hoping to get. I also think that, there are so many bottlenecks in this software delivery process. Maybe you can get more out of the AI investments that you're making by looking at how can we leverage AI in some of those areas. So I think that's really important as well. Using AI throughout the entire software delivery lifecycle, not just on code generation.
Yeah. I think it's also, I like to say, like, nobody made us prove the ROI of, integrated development environments of IDEs, right?
Yes.
And of course, those are largely free now too, but I don't recall being asked to prove that I shouldn't be using, a text editor to get my work done. So I think it is good to keep this in perspective, that, it is just another tool in our toolbox. So were punch cards once upon a time.
It is, and that's kind of the double-edged sword, I think, of having that organizational prioritization, that really top-down mandate, thou shalt use more AI, really kind of leads us towards these conversations around, well, what's the return that I'm getting on that? I don't remember any CEO or like top-level leader coming and saying, thou shalt use an IDE as you develop code.
Yeah. And that is, like, if you're laughing at that, those of you in the audience laughing at somebody up top mandating the use of AI, that's for real. That is really actually happening, or at least senior leaders are mandating it. That creates interesting situations.
It is a conversation in boardrooms happening right now.
Yep. Yeah. Absolutely. So one other question before we wrap up. Looking at the benefits of AI adoption, we're looking at high-level averages and a necessary level of abstraction. And, like, at the end of the day, this is all qualitative data that is being turned into quantified quant data, right? Like, we're starting with surveys from humans. So and I don't know how much you do this, but when you zoom into a specific team or department, or like, do you slice and dice, and do you see any places, any occasions where this AI impact seems to actually be higher than the average? Obviously, somebody's higher than the average. So,
yes.
Is there anything that correlates with being higher than the average?
Yeah, I think kind of by definition, half or so of the people are better than the average, right? So I think this is I think this is also where it's a good moment to kind of step back and remember that the numbers that we're looking at, we basically took our very complex model, which is just a model. There's no way that our model accounts for everything, every condition, every aspect of how a team works. All right, so it's already a flawed model, hopefully useful, but flawed nonetheless. And then in that model, we changed one variable, right? We cranked up the AI adoption factor by about 25% to see what are the impacts across that model. The truth is, in an organization, it is extremely difficult, maybe impossible, to change just one thing in the entire organization and see what is the impact of that. So I think that you're obviously obvious to me, maybe. You're almost necessarily going to see numbers that are very different than what we see as we look at the world, because you don't work for the world, you work for a team in a context, and the adoption that you have and the enablement that you have and the tools that you have available are all factors that drive this. So I think again, using our numbers as kind of, hey, here's a baseline of what we see across the industry. That's really good to know. That can help me individually or on my team create a hypothesis. And so we see pretty clear signals of things that are improving. Maybe those are good places for you to invest in.
Yeah. Well, Nathen, I could and did talk to you for a whole lot longer about this. So I dropped the link to our podcast recording from a couple months ago if you want to hear more from Nathen. But thank you so much. This is insightful as always. I have 10 more questions I want to ask you. But up next, we have Mary Williams joining us.